Today, we want to learn about the arc length of the parametric curve. We have a parametric curve, so the curve has a direction. It doesn't have to be one direction. It can go forward and backward. We have parametric curve, so each component is defined by a function. Let's say x equals f of t and y equals g of t, and t is defined from alpha to beta. And we also assume that f prime and g prime are continuous on the interval alpha to beta. We will not spend the time to derive the arc length formula, but you can derive that formula pretty easily. The end conclusion of the arc length formula for the parametric curve goes like square root of, it looks like a Pythagorean formula, dx dt squared plus dy dt squared dt. Of course, you have to remember all the formulas. The question is, find the exact length of the curve x coordinate is defined with 3 cosine of t minus cosine of 3t, and y coordinate is defined with 3 sine t minus sine of 3t. T runs from 0 to pi. By the formula, we have to calculate the derivative of x and y with respect to t. So dx over dt equals minus 3 sine of t, and then cosine's derivative is minus sine t, so minus minus will make plus, plus sine t, but we have to apply the chain rule, so we would write 3 here times sine of 3t. Any question? If there is any ambiguity, then you will write that down on the chat box and I will explain more details. dy over dt is 3 times cosine of t by the formula. By applying the chain rule to the inner function 3t, we get 3 cosine of 3t. In the arc length formula, under the square root, we had dx squared, dx dt squared plus dy dt squared. So we have to calculate all those. So minus 3 sine of t plus 3 sine of 3t squared plus y is 3 cosine of t minus 3 cosine of 3t squared. So expansion formula we will use will be a minus b squared is a squared minus 2ab plus b squared. So what's happening here is both are the same pattern. We just switch the order of addition. So each term squared, so sine 9 sine squared of t and minus 2 times, let's just write down 3 sine of t times 3 sine of 3t plus the second one's squared, so 9 sine squared of 3t. And then the next one, we expand that with the same principle. So that becomes 9 cosine squared of t minus 2 times 3 cosine of t times 3 cosine of 3t plus 9 cosine squared of 3t. So we want to apply the Pythagorean formula to simplify further. We'll combine these two. Then from here, we get 9 sine squared of t plus 9 cosine squared of t. And we have exactly the same thing. From here, we have the same thing. So each one will produce 9. So both are 9. So 9 and this one 9 plus 9 minus 2 times 3 will make 6. 6 times 3 will make 18, right? So 18 is a common factor when we consider this part. So this one is something like sine t times sine of 3t plus cosine of t times cosine of 3t. So what we want to do from here is we want to simplify this part a little bit further. Then cosine of a minus b equals cosine of a times cosine of b plus sine of a times sine of b. So we are going the reversing pattern. So we are thinking about the differences between two. And cosine is an even function. It doesn't matter whether you do t minus 3t or 3t minus t. Both can be written as 2t because cosine of 2t is cosine of negative 2t. Cosine of 2t equals cosine of negative 2t, because even function property. So the first part will produce 18. And then second part will produce 18 cosine of 2t. 18 is a common factor, so we take out then 18 times 1 minus cosine of 2t. The formula from the trigonometry is like this. Cosine of 2a is cosine square root of a minus sine square root of a. And then we can write 1 minus sine square root of a minus sine square root of a from the Pythagorean formula. Then it can be written as 1 minus 2 sine square root of a. So this is what we want to use. So this one will be 18 times 1 minus, instead of cosine of 2t, we will write 1 minus 2 times sine square root of t. So that is 18 times, let's go through all those details. Minus will be distributed to both, not only to the first term. So 1 minus 1 minus minus will make plus, plus 2 sine square root of t. So those will cancel each other. And 2 times 18 will make 36 and sine square root of t. So we are completing this squared part, dx over dt squared plus dy over dt squared equals, we calculated what's under the radical. That will be 36 sine square root of t. That is 6 sine of t. So the length is from 0 to pi, because t is running from 0 to pi. That is dx dt squared plus dy dt squared dt. And we calculated this part and got 6 sine t. So 0 to pi, 6 sine of t dt. If you integrate, then you will get minus cosine. So minus 6 cosine of t from 0 to pi. So we plug in pi to the expression, then we get 6 cosine of pi plus 6 cosine of 0. And then we have to know what the cosine graph. Cosine graph look like this. Cosine start at the maximum point, and this is pi, and this is 0. So at pi, cosine value is minimum. So minus 6 times minus 1 plus 6 times at cosine 0, that is the maximum value 1. So the first one is 6, the next one is also 6, so that becomes 12. Any question? No question? In this example, what we want to see is, of course, we want to calculate the arc length of the parametric curve. But what we want to emphasize in this example is the arc length of the parametric curve is not the same as general notion of the length of the curve. At the end of this problem, you will know what that means. The first question is find the distance traveled by a particle with position x and y as t varies in the given time interval. The which one are you talking about? Wouldn't be cosine 3t. Are you talking about this, Ellen? In the previous problem, which part of previous problem are you talking about? The which part there was cosine and sine 3t, but when we apply this formula, we thought about the differences between two angles, and that is 2t, right? And so we end up getting 2t. However, we used this double angle formula for cosine again. So double angle became just an angle.
Could I see that one more time on
What?
on the last page? The trig formula you used, the cosine of a minus b.
Yeah.
Perfect. Thank you.
Any other question? There are many trigonometric formulas, and those are the things you already learned in trigonometry, but it's really hard to retain all the memories. So you have to, as I said, you have to get the formula sheet. I mean, make the formula sheet, and you have to repeat it, and you have to memorize those formula. Let's go back to the beginning. Consider x equals 2 sine squared of t and y equals 2 cosine squared of t. And t is from 0 to 4 pi. What we want to think about is find the distance traveled by the particle in the position as t varies in the given interval. Well, later point we will clearly show that that is something like this. It moves forward and backward. So the meaning of this question is we don't calculate this line segment's length. That is not the arc length we are looking for. What we are looking for is more about what is the distance traveled by the particle. It can go up to here and then go back, and then the distance will double. And the arc length formula will be consistently calculating or include all the calculation about the distance traveled by the particle. So the first step is calculating the derivative of x. So that is 2 times, again, we are thinking about the chain rule. The external function is x squared and internal function is sine t. So we calculate the external function's derivative, which is 2 sine of t, and then multiplied by the internal function's derivative, which is cosine of t. So that ends up being 4 times sine of t times cosine of t. And then dy over dt equals, we calculate this part, then that is 2 times 2 cosine of t times minus sine of t. That is just the formula for derivative of the sine. So minus 4 sine of t times cosine of t. Can I move on? Now, we want to calculate what was under the square root. That is dx over dt squared plus dy over dt squared. And so dx dt is 4 sine of t times cosine of t squared plus dy dt is minus 4 sine of t times cosine of t squared. So each one will become 16 sine squared of t cosine squared of t. Let me just write down 16 sine squared of t times cosine squared of t. So we are adding both, then 32 sine squared of t times cosine squared of t. And then what we will try to do is we want to simplify this part. Then we will write 32 as 8 times 4. Then that becomes 8 times 2 sine squared of t times cosine squared of t. No, 4. The reason we are breaking that into 18 times 4 is something like this. 8 times this one can be 2 sine t cosine t squared. And then we will use the formula, double angle formula for sine. That is sine of 2t squared. So double angle formula for sine is sine of 2t equals 2 times sine t times cosine t. You have to remember this. Any questions so far? Now we are ready to calculate the distance traveled. That is from 0 to 4 pi. So square root of 8 times sine of 2t squared dt. Integration 0 to 4 pi. So of course, we can write this one as square root of 8 times square root of sine of 2t squared dt. So 8 is 2 times 4. So that is from 0 to 4 pi times 2 square root of 2 times absolute value of sine of 2t dt. And then we have to be careful when we proceed the calculation because sine can be positive or negative between 0 and 4 pi. So we will consider the graph of sine of 2t. So y equals sine of 2t. And then we already know the period. Period is 2 pi over 2, which is pi. And then we know that there is a notion of key points. So that is 0 to pi. And this is pi over 2. And this is pi over 4. And this is 3 pi over 4. And we are considering the sine graph. So it starts at the origin and then it goes up and down. When we transfer that to the XY plane, like this. And what we know about this, the characteristic of the sine graph is this area and that area are the same area. The reason we are thinking about that is we are thinking about the absolute value of sine of 2t. And we are considering the interval from 0 to 4 pi. So we have to figure out how many periods are included in the interval 0 to 4 pi. We know that there are 4 periods between 0, and 4 pi. Because one period is pi. Any questions so far about the trigonometry, which you cannot remember? If you go to the course website, then you can see some remediation with trigonometry, so you can refer to it. We go back to this point. It is from 0 to pi, and there are 4 periods. And within one period, there were 2 regions. The one region is a positive and the other region is negative. We are thinking about the arc length formula, which must be always positive. And so what we will do will be, we will calculate this area, positive area, and then for each cycle, there are 2 of this, right? Just so all the area will be twice of the integration from 0 to pi. 0 to pi over 2. And the other part is just copying 2 square root of 2 sine of 2t. So I just remove the absolute value sign here. But important point is there are 4 period, and so there are 8 bumps, right? So 1, 2, 3, 4, and it goes on and on up to 8. And so we write 8 here because that is 8 times more. Any questions so far? Then let's keep on going with the calculation. That is 16 square root of 2 integration 0 to pi over 2 sine of 2t dt. So that is 16 square root of 2. That equals minus cosine of 2t over 2 from 0 to pi over 2. So that is just the integration formula. So this 2 and this one will cancel and become 8. So 8 square root of 2 and minus cosine of 2 times pi over 2, and then plus cosine of 2 times 0, which is 0. So it becomes 8 square root of 2 times cosine of 0 minus cosine of pi. And the cosine function look like this. So this is pi and this is 0. No, this is 2 pi, this is pi. So it becomes 8 square root of 2, cosine of 0 is 1, minus cosine of pi is minus 1. So 8 square root of 2 times the next one is 2, which is 16 square root of 2. So this is the distance it traveled The next question is comparing the arc length with the length of the curve. So we were thinking about the distance the particle traveled. I don't know how many times it traveled, but I believe it is 8. But anyway, it travels here and here. The next question is about calculating the length of this line segment. And then we will see that the length of the line segment is different from the distance the particle travels. And so this example shows that the arc length with the parametric curve is not the length of the curve. Instead, that is the total length of the particle traveled along the curve. So the second question is, what is the length of the curve? So again, this question is purely about what the length of the curve, and this question, the previous question, is distance traveled by particle. So in this question, x equals 2 sine squared of t, and the y equals 2 cosine squared of t. So what we notice from here is when we add x and y, it becomes 2 times sine squared of t plus 2 times cosine squared of t. So x plus y is 2 open parenthesis sine squared of t plus cosine squared of t. So this part equals 1. So we end up getting x plus y equals 2. So we can solve for y, then y equals 2 minus x. We know that slope is -1 because -1 is multiplied to x, and y-intercept equals 2. Of course, the x-intercept must be 2 also. So we end up graphing this line segment. Even though this equation's line can be extended, we are drawing the equation of the parametric curve. So we don't extend the curve beyond this. This is 2 and this is 2. Why is that? What we know about the range of sine is sine oscillate between -1 and 1. So in this problem, what is given is 2 times sine squared of t. So that is 2 times sine squared of t. That was x. So if you multiply by 2 here, then that is 2. And the sine value is 1. So 1 squared is 1. And so it should be less than or equal to 2. But as you can see, this is greater than or equal to 0. And this is a positive number. And so entire thing must be greater than or equal to 0. The next one is about cosine of t. Cosine of t is from -1 over 1 to 1. And we do the same reasoning. 2 times cosine squared of t equals y. And that is from 0 to 2. So what I was trying to say is the graph of this straight line is extended forever. But when we limit ourselves from x range between 0 to 2 and y range from 0 to 2, we get only this line segment. So we can just apply the Pythagorean formula. Two legs lengths are both 2. So length of the curve is the same as square root of 2 squared plus 2 squared. What I'm using is a hypotenuse squared is a squared plus b squared. And so c equals square root of a squared plus b squared. So that is 4 plus 4, which is square root of 8. And then this is 2 times 4. And so that becomes 2 square root of 2. And so that is the length of the curve. And the particle it traveled was 16 square root of 2. So it was going back and forth 4 times, right? Any question about what you learned today? Recent course material are related to the past trigonometry course materials. As I said, I included the remediation with the trigonometry course in our course website. So if you cannot remember something, then you can refer to it. And next time, what we will learn about will be actually review will be polar coordinates. That is something we already learned in trigonometry. And then we will review polar curves. Very first page in this class hour or in this problem. Do you have any question about what I taught today? Hopefully you will do better in the second exam. Especially you have to go through the past quiz problem, including yesterday's quiz you have to remember. And so make sure that you understood those fundamental problems you worked together during the activity hours. And if you don't just if you just come and sit down and work out the problem with others and then you forget how to solve it, and then that activity hour is not very meaningful. As I said, you have to master it. And when quiz problems are given, those are pretty essential and fundamental problems which can be useful for the exam purpose. But of course, the exam range is a lot broader than what is given, the problems given during the class hour. So you have to go through all the lecture note. Keep studying hard and hopefully you will get a lot better score than previous one, and you can smile at the end of the semester. That's what I hope. So see you tomorrow.